Hello, my name is Anshuman, and today we are going to discuss about predicting employee attrition. We are part of Group 10, and the teammates are Anshuman Roy, that is myself, followed by Laksha, and finally Jagdish. So let's talk about the business issue. Why attrition matters. Voluntary turnover averages around 23% annually, and the cost is quite high. That is 50% to 200% of each salary. Beyond hiring cost, there's definitely loss in productivity, disruption in projects, and of course, knowledge drain. So reducing avoidable attrition is a direct path to margin protection. What is our goal? Our goal is to build an early warning system that flags employees at risk of leaving, enable targeted retention actions before resignation letters arrives. Finally, align talent strategy with business growth and diversity, equity, and inclusion commitments. Let's talk about the data. So you have got a data set from Kaggle. The data set is related to IBM HR Analytics dataset. It has close to around 1,470 anonymized employer records. It features 35 features, column that is, which includes demographics, role, compensation, performance, engagement, among others. In regard to the dataset, 16% has historical attrition and 84% are active employees. I'll give it to the next speaker. Thank you so much.
Thank you, Ankushman. Our analysis of this data revealed several powerful patterns that predict attrition. First, we confirmed that compensation is a critical factor. Low monthly income is a primary driver of risk. And this is made worse when we combine with lower stock option levels. Next, overwork and travel impact are significant. Working consistent overtime is a strong predictor of an employee leaving. And for those who also travel frequently for business, the risk is doubled. Finally, tenure and experience matter. Our data clearly shows that younger employees and those with less than 3 years at the company are at high risk group. Based on these findings, we chose our predictive model not just on technical power but on 3 core business principles. First, performance. The model had to be highly effective at identifying employees truly at risk. Second, transparency. The logic behind every prediction needed to be clear and explainable for our HR partners and for legal review. And finally, fairness. We ensured the model has built-in checks to prevent bias and a low false positive rate to protect employee morale. After thorough evaluation, we can confirm the gradient boosting model delivered the best balance of these principles. The model gives us 81% accuracy and successfully identifies 60% of likely exits. It confirmed that the top drivers are overtime, monthly income, job role, and most importantly, it provides transparent personal level explanations for HR for every single prediction. So how does this become a practical tool? The system will be integrated directly into HR workflows. HR business partners and line managers will receive a weekly risk dashboard. Automated alerts will trigger tailored retention playbooks, allowing for proactive conversations. And it's a continuous learning loop. The model is updated after each exit interview, so it gets smarter and more effective over time. Now, Daksha will discuss the deeper insights this model unlocks and our plan for the future.
Thank you, Jagadish. The real value here is that our model generates smarter insights by analyzing combinations of behaviors. It allows us to pinpoint the complex risk scenarios that are otherwise difficult to see, such as identifying high performers who are unhappy, new joiners who are in stressful roles, or employees who may be underpaid for their experience. This adds critical real world context to every predictions. Yeah, so the expected business impact. So these smarter insights translates directly into significant business impact. Our primary target is to cut voluntary attrition by 15% in the first year alone. For an organization of 1,000 people, we estimate this will lead to an annual savings of $2.4 million. Beyond the financials, we expect to see improved morale and a stronger employer brand, which benefits our entire talent pipeline. Risks and mitigations. Of course, an AI powered system in HR comes with greater responsibility, and we have planned for the key risks. To mitigate bias, we will conduct quarterly fairness audits and feature reviews. To protect privacy, the system uses role based access and data encryption. And to ensure regulatory compliance, we have aligned with the GDPR and EEOC AI guidance. Most importantly, To prevent over reliance on technology, a human in the loop will always make the final decisions. So the next steps. So what are the next steps to make this a reality? We propose a pilot program in Q3 of this year, focusing on the sales and R&D teams, which covers about 300 employees. During this pilot, we will refine the models thresholds using live feedback from managers. Following a successful pilot, we aim to an enterprise-wide rollout with the full KPI scorecard by the first quarter of 2026. So that was it. Thank you for your time. We are now happy to have answer any of your questions if you have. So thank you so much. Thank you. We will now begin the technical walkthrough with our first notebook, data cleaning, where we take the raw data and prepare it for analysis. We start by importing the required libraries, mainly using pandas for data handling. The dataset contains 1470 employee records and 35 columns, with attrition our target variable. We examine the structure of the dataset and using .head and .info functions to get a quick overview of the data types and values. Next, we checked for the missing values, and the good news here is that there were no null values in any column. And we also checked for duplicate rows and found out zero duplicates, which means the data is clean in terms of repetition. Finally, we identify some columns like employee count, count over 18, standard hours, and employee number that had constant unique values. So we drop them as they don't add value to our model. So this clean dataset is now ready for further analysis and modeling steps. Now I'll walk you through the exploratory data analysis. We start by importing the necessary libraries for data analysis and visualization, pandas for data handling, matplotlib, and seaborn for plotting. We load the clean dataset and drop four non-informative columns like employee number, standard hours. After dropping, we are left with 31 meaningful columns. Now we categorize the columns into three types: continuous like age, monthly income, years at a company; ordinal like education, job satisfaction; categorical like gender, department, and attrition. So now here are some interesting findings. Age, most employees are between the age 30 to 43. Monthly income, there's high variation with a long tail of high earners. Attrition, only 16% of the employees have left the company, which means we're dealing with class imbalance. Here we can see the feature interpretation and observations. So next, we generated a histogram and bar plots to visualize distributions. Most ordinal features like job satisfaction and environment satisfaction skewed towards higher values, showing generally positive employee sentiment. So this is the ordinal feature bar charts. You can have a look here. And this is the feature interpretation for this. And now in the bivariate analysis using box plot, we discovered strong signals for attrition. Next is the ordinal feature versus attrition group counter plots. So these are the plots which we have received. And then here is the feature and interpretation by attrition. So this is also the analysis of predictive power among ordinal features for employee attrition. So next we have done the categorical feature versus attrition group counter plots and the interpretation and features. Next is the target variable distribution. So this is the attrition class distribution. So after seeing this, we have found the key observations as majority class. No, the dataset contains approximately 1,233 records of employees who did not leave. Minority class, yes, there are only about 237 records of employees who did leave. So the attrition rate is approximately 16%, confirming that yes class is heavily outnumbered. So yeah, so these are the implications for modeling. So this imbalance is critical, finding that must be addressed in the modeling phase. So next is the model biased. If left-handed model may become biased towards majority class, no, achieving a higher accuracy but failing to predict the actual attrition. The next is the evaluation metrics. So accuracy will be poor and misleading performance indicator. It is crucial to focus on the metrics like these: precision, recall, F1 score, so on. Next are the strategies. So techniques such as SMOT to over sample the minority class using the class weight balanced in the algorithms like regression and random forest will build a robust model. Correlation heat map. This heat map shows how strongly features are linearly related to each other. Correlation values range from -1 to +1. So +1 means that it is a strong positive correlation. 0 means no correlation. -1 means strong negative correlation. So from the heat map, we notice some strong positive correlations like total working years and monthly income. As expected, more experience often leads to higher income, and years at the company, years with the current manager, and years at the company. So these are all tenure related and naturally linked. Also, there is no multi-collinearity issue among high correlated redundant variables. But we'll keep this in mind when selecting features for modeling. In summary, our EDA helped us clean and simplify the dataset by removing irrelevant columns. We analyzed distributions of continuous, ordinal, and categorical features. Key findings included employees who left the company tend to be younger, have lower monthly income, shorter tenure, and less time with their manager. Most employees rate high on satisfaction and involvement and work in R&D or sales. So there's a clear class imbalance in attrition with only 16% employees having left. These insights will guide our feature selection and modeling going further. Thank you so much.
This notebook analyzes employee attrition using IBM HR Analytics dataset, which we have discussed earlier. In this file, what we are going to do is to apply random forest for classification and interpret results using visualization, metrics, and explanations. Then we move to the data processing side. So we first converted the target variable attrition into binary format, which is yes was mapped to 1 and no to 0, making it suitable for classification. Next, we selected a subset of relevant features based on domain guidance, continuous features like monthly income, age, total working years, ordinal features such as job satisfaction and work-life balance, categorical features including overtime, marital status, and job load. We ensured that all the selected features were copied into a new working dataset for further processing. We also checked for missing values. So for continuous and ordinal features were imputed with their median values, and categorical features were filled with most frequent values. There is a mode. We also checked for categorical features, which were split based on encoding needs. For example, the binary and ordinary features for like overtime were encoded using label encoder. Nominal features like job load department were transformed using one-hot encoding. And this whole section is doing that action which we discussed. And while doing the data processing, we found a new feature, that is the high-risk profile, which was created to identify likely attrition cases. It flags employees at high risk if they work overtime, have no stock options, and low job satisfaction. Otherwise, they are marked as zero. This dataset was then split into training and test sets using a ratio of 80:20. Then we trained a random forest classifier with 100 decision trees and fixed random seed for reproducibility. The model was fitted on the training data. Then predictions were then done on the test set. Finally, we evaluated the performance using the classification report. While doing this, we also use the training random forest model to compute the feature importance. The top 10 features contributing most to attrition prediction were visualized using a bar chart. This helped identify key features like overtime, monthly income, and job role. We also employed SMORT, which synthetically generates new minority class samples by interpolating between neighbors. The original dataset was quite imbalanced in this case, with far fewer yes cases. So this helps model learn better with the yes cases without overfitting. Then we again calculated the confusion matrix and also the ROC curve as well. Then what we did is that we trained a random forest model with class weight balance to handle class imbalance. So this setting gives us higher weight to the minority classes, improving sensitivity to underrepresented labels. After training, we predicted on the test set and evaluated performance using a classification report, which included precision, recall, and effort score, namely the confusion matrix. Next, what we did is hyperparameter tuning with the randomized search CV. So we use randomized search CV to optimize random forest hyperparameters for better model performance. And this code talks or takes us through that cycle. And after that, again, we calculate the confusion matrix and, of course, the tuned AUC ROC curve. Then what we did is that we between the untuned and the tuned model, we did a confusion matrix comparison. Okay? And this section talks about that, about true positives, false negative, false positives, true negatives, and so on and so forth. Though the ROC AUC curve for the untuned and the tuned one was showing 0.79, but the conclusion is this. We successfully built and tuned the random forest model to predict employee attrition using the IBM HR dataset. Both the untuned and the tuned models achieve the same ROC AUC score of 0.79. That this tuned model significantly improved recall. True positives increased from 6 to 20. False negatives dropped from 41 to 27. Although the false positives increase, this is acceptable in an HR setting where it is better to flag more employees than to miss actual attrition risk, which is very important. The final model tuned using randomized search CV and the trained on the original data provides a reliable way to proactively identify at-risk employees. Thank you so much. I'll give it to the next.
Now that Angushman has covered the random forest model, we'll dive into our second and ultimately recommended candidate, XGBoost. This notebook details a more sophisticated and iterative process where our primary focus was maximizing the model's ability to identify at-risk employees. To enhance a model's predictive power, we went beyond the standard features and engineered several new ones. knowing from our EDA that we had a significant class imbalance. We didn't just train a base model, instead, we methodically evaluated 3 alternative remedies to find the optimal approach for maximizing recall. As you can see in the comparison table in the notebook, we tested using scale pass 8 only, using smooth oversampling only, and finally combining smooth with moderate scale pass weight. Our analysis concluded that combined strategy delivered the best balance, giving us a significant lift in recall without a major drop in overall accuracy. This became our chosen baseline for fine-tuning. We then took this optimized baseline and performed extensive hyperparameter tuning using randomized search CV, explicitly setting our scoring metric as a scoring metric to recall. The final tuned model achieved an accuracy of 81% and most importantly recall of 0.60 for the attrition class. To ensure models is not a black box, we used sharp plots. These visualizations confirm that factors like overtime, stock option level are the most influential, and most importantly, they allow us to explain the specific drivers behind any individual employee's risk score, providing the transparency needed for HR to act confidently on these insights. Finally, this brings us to the conclusion of our modeling work. Our analysis confirmed that the final tuned XGBoost model is highly effective. It delivered an 81% accuracy. And most importantly, our business goal of recall 60%. This means that it successfully identifies 60 out of every 100 employees who are likely to leave. We also noted that the decision threshold can be tuned to capture even more at-risk employees up to 85% if the business is willing to accept more false positives. Our feature importance and app analysis also pinpointed most influential feature drivers of the attrition. As expected, working overtime is a top factor, followed closely by an employee stock level option and the tenure within the company. Based on the model's performance and these key drivers, we outlined 4 actionable recommendations for HR to consider. With both models fully tuned, we move to our final evaluation notebook where we make our definitive recommendation. Here, we consolidated the final metrics from both the random forest and XGBoost models into a single summary table. The visualization make the story clear. While both models have a similar overall accuracy and ROC AUC scores, the third chart showing the key metrics for the attrition class is the most important. You can see clear trade-off. Random forest is slightly more precise, but XGBoost has a significantly higher recall. Okay, so our conclusion is driven by the primary business objective to identify as many at-risk employees as possible. For this reason, recall for the S class is the most important metric. The XGBoost model achieved recall of 0.60, which is substantially better than the random forest 0.43. While both models had the same precision, XGBoost's ability to find more true attrition risk makes it clear choice. The cost of false negative, failing to identify an employee who then leaves, is far greater than the cost of false positive. Therefore, XGBoost classifier is our recommended model for the deployment. Now that we have selected our final model, the last step is to outline how we will get it into production and ensure it works reliably. This is detailed in our deployment notebook. Our strategy is to deploy the XGBoost model as a real-time REST API using a fully managed AWS SageMaker stack. This approach provides scalability and reduces operational overhead. As you can see in our architecture diagram, the workflow is end-to-end. Client request from the HR portal comes through an API gateway to a SageMaker endpoint. This endpoint pulls live features from the SageMaker feature store to make predictions. To ensure the model works long term, we have a 2-part plan. First, for monitoring, the live endpoint will be watched by Amazon CloudWatch for service health and by SageMaker Model Monitor to detect data and model drift. Second, for maintenance, we will use SageMaker pipelines to create automated retraining workflow. This pipeline will be triggered on a schedule or by a drift detection, and it will automatically train, evaluate, and deploy new versions of the model to keep it performant. This deployment plan provides a robust and scalable and automated solution for turning our data science asset into a real business tool. This concludes our technical walkthrough. Thank you.